Now we are going to discuss the question from signals and systems given in GATE 1999. So here it is related to the Fourier series. So the Fourier series representation of an impulse is train denoted by s of t equals to integral summation n equals to minus infinity to infinity d of t minus n capital T naught is given by. So here we need to see the Fourier series representation for this s of t here. So coming to the solution, so here s of t is given as s of t equals to summation n equals to minus infinity to infinity d of t minus n t naught is given. So this is nothing but impulses. This is impulses train, nothing but this is del of t minus n t naught, nothing but this is like having the shape from minus infinity to, let us consider this is at minus 1. So given that this is n t naught, so this is at minus t naught, this is at minus t naught, and we have at 0, and we have at t naught to t naught, like that we have up to infinity. So this is a periodic signal, this is a periodic sequence. So we need to find the Fourier series representation for this one. So by writing the Fourier series representation, we know that the exponential Fourier series for s of t is taken as s of t equals to, that is summation n equals to minus infinity to infinity. We will write it as Cn into e power j 2 pi by t naught n t. Here t naught is nothing but the period, we will write it as 2 pi by t naught n t. So this is the Fourier series, discrete Fourier series representation. Now we need to find this constant Cn here. So in order to find the constant Cn, we have the expression for the Cn equals to that is 1 by t naught integral 0 to t naught over the period t naught. This is s of t into e power minus j 2 pi by t naught into n t. This is the expression for Cn. Now we need to find this value of this integration. Now we can observe that over 0 to t naught, within this period 0 to t naught, within this period we have the impulse only del of 0, here. So del of 0, only at del of 0, then this entire integration, then this integration Cn is equals to 1 by t naught into this is del, this becomes s of 0 only at s equals to 0. So we'll get this as minus e power minus j 2 pi by t naught n and this is equals to 0. Then the Cn value becomes 1 by t naught. So this s of t have only the value at t equals to 0. That's why that value s of 0 value is equals to 1. That's why the value Cn becomes 1 by t naught. So finally the DFS representation, discrete Fourier series representation, is s of t equals to, that is summation n equals to minus infinity to infinity Cn into e power j 2 pi by t naught into nt. Here Cn equals to 1 by t naught we got, so 1 by t naught summation n equals to minus infinity to infinity e power j 2 pi by capital T naught nt. So this is the discrete Fourier series representation of train of impulses. So we'll see the answer here. Out of the 4 options, the option D is the correct answer.